So we talk about quicksort being turned into mergesort. We have the values over here, and I mentioned that it's being done with mathematics. But once we have that, once we have those variables, we can do the merging with these 4 lines right here. And I'm going to show you how it works. Basically right here we have partition A and partition B, and that's the parameters low and high, just like quicksort. And then we set the iteration value. Now this one, that's J basically kind of like the log n part, and I basically the n part, so basically it's n log n. Now the J basically puts the values right here. That's J0, that's J1, that's J2, and these are I0, I1, I2, I3, and 4. So together it becomes n log n. Next, we want to check over here. We want to check whether or not the list is already ending. If so, we put all the range, the ending part, the PA2, PP1, and PP2 to the end of the list. And that's it. Just to make sure we don't go past the list. Now over here is a little optimization part. If A2 is less or equal to B1, then we don't need to do anything. This is the first line. Basically, this is as long as there are elements in both A and B, we set the buffer to the contents of, depending whether or not A or B is smaller. If A is smaller, put the elements on A. If B is smaller, put the elements on B. So that's the first line. And this is the basic implementation of it. Notice that a label MG1. That's because over here we have PA1, PA2, and that's go to MG1. So go back there. Now this loop is actually not a while loop as implemented. This loop is actually a repeat until loop. That means it's guaranteed to be executed at least once. But once I have this line over here on top, that's fine, because that will take care of it. Take care of the situation where there is nothing in there. So that's the first condition. This is the second condition, that there is some elements in the A, but nothing on the B. Just copy all the elements on the A to the B right here. And this is the third condition. Same thing, just do it with the B. And this is the fourth condition, which is everything is done. So we want to copy back from the buffer to the original list. Now I'm using K instead of I over here. This is I, but the reason I'm using K is because I'm already using the I as the iterator for the values. So I'm using K over there. And that's it, we're done. So next I, next J, and return, and that's the whole thing. And the nice thing about the mergesort is that the running time is stable. If it sorts everything in 33 flips, then it will always do it in 33. Sometimes 32, sometimes 34, but the range is a lot narrower than quicksort, so it's very stable. And you don't see it, but it's actually stable order. That is, if the values has the same value with comparison, then the order of the elements in that list is maintained. And you can see it's slowly going. piece by piece, and the lines becoming thicker and thicker and thicker as the partitions are becoming bigger and bigger and bigger. And really, the best way to do this is by bottom-up iterative. I don't see why anybody would want to do it top-down recursive. I mean, that's how they say it in the Wikipedia, but I don't believe it. I mean, merge sort is basically a way to remove recursion from quicksort, and they even put, memory for explicit stat. And I'd say if you gonna spend that much memory anyway, best to use merge sort, because merge sort would then be desirable. Because you are going to have the memory anyway, so let's use it for the sort that lets you use the memory and maintain stable order. Basically, you have a choice. You can have fast sort, you have a stable sort, and you have efficient that does not use memory sort, and you have to pick two. You cannot have three. So merge sort is the one that is fast and use memory. Quicksort is the one that's fast, does not use memory, but it's unstable. So merge sort is fast, stable, and uses memory. Quicksort is fast, unstable, and uses no memory. And that's about it. And that's really, merge sort is the best and final quicksort form, in my opinion.